What if I told you NASA is preparing a new message for aliens, but this time it's not just a friendly hello? For decades, we've stared into the silent, black void of space and asked the same question: are we alone? We've sent postcards into the cosmos, hopeful greetings in a bottle, tossed into the cosmic ocean, but the universe has remained stubbornly quiet. Now, the strategy is changing. It's no longer just about shouting into the dark. It's about preparing for the day someone or something finally answers back. NASA and its partners have developed new protocols for first contact and are using simulated alien signals to rehearse. The technology they're pioneering could change everything we thought we knew about the search for life. This isn't a story about a single message. It's about a fundamental shift in how we approach the greatest mystery of all. We're going to break down the unofficial rulebook for alien contacts, the global dress rehearsal that used a fake alien signal, and the incredible laser technology that's rewriting the future of space communication. What's happening right now isn't what you think. Section 1. The Great Silence and the Cosmic Postcards. For as long as we've had the tools to listen, the overwhelming soundtrack of the universe has been silence. There's a name for this profound, unsettling quiet: the Fermi Paradox. The universe is vast, filled with billions of galaxies, each home to billions of stars. Statistically, there should be countless planets capable of supporting life, and some of that life should be intelligent and technological. So, where is everybody? This question has haunted scientists for generations and is the driving force behind the search for extraterrestrial intelligence, or SETI. Our first attempts to break the silence were bold, creative, and deeply optimistic. Think of them as planetary messages in a bottle. In the 1970s, NASA launched the Pioneer 10 and 11 spacecraft with small, gold anodized aluminum plaques bolted to their sides. These plaques featured engravings of a man and a woman, a diagram of our solar system, and a cosmic map showing our sun's position relative to 14 pulsars, a simple, elegant "you are here" sign for any interstellar traveler who might stumble upon them. But our most famous cosmic greetings are the golden records carried aboard the Voyager 1 and 2 spacecraft. Led by a committee chaired by the legendary astronomer Carl Sagan, the Voyager team curated a time capsule of Earth. These gold-plated copper records contain sounds and images portraying the diversity of life and culture on our planet. There are greetings in 55 languages, the sounds of wind and rain, the songs of birds and whales, and music from Bach to Chuck Berry's Johnny B. Good. The records also include 115 images, showing everything from mathematical definitions and our DNA structure to scenes of human life. These were messages of peace and friendship, our introduction to the galactic neighborhood. Then there was the Arecibo message. On the 16th of November, 1974, the Arecibo radio telescope in Puerto Rico broadcast a powerful focused beam of radio waves toward M13, a star cluster 25,000 light-years away. This digital message, designed by Frank Drake and Carl Sagan, was a bitmap image of just 679 binary digits. If arranged correctly, it reveals a simple infographic of our number system, the elements of life, our DNA, a stick figure human, and our solar system. These early attempts were beautiful, hopeful gestures, but they were also like shouting a single word into a hurricane. The Arecibo message will take 25,000 years just to reach its destination, and we'd have to wait another 50,000 for a reply. The problem isn't just sending a message, it's the mind-boggling scale of the universe. The radio waves we've used are a tiny flashlight in an endless forest. And even if someone hears us, what happens next? This is where the story takes a turn. Scientists realize that shouting into the void without a plan is reckless. The optimism of the 70 seconds has given way to a more cautious, strategic approach. It's no longer just about saying hello. It's about being prepared for the conversation. Section 2. The Secret Protocols for First Contact. What happens the moment a radio telescope picks up a signal that isn't just cosmic noise? Who do you call? What do you say? For decades, this was a serious gap in our global planning. Answering it has led to the creation of what you could call the unofficial protocols for first contact. These aren't classified documents in a vault. They are guidelines developed over decades, primarily by the International Academy of Astronautics, IAA, and its SETI Permanent Committee. The foundational document, first drafted in 1989 and updated in 2010, is the Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence. Recognizing how much the world has changed, the IAA formed a task group in 2022 to completely re-examine these protocols for a new era. Drafts of these new principles were presented at the International Astronautical Congress in 2024. And the multi-year revision process continues with the goal of presenting a final version to the world in 2026. So what's in this critical rulebook? It breaks down into a few key steps. First, asterisk, asterisk, verification, asterisk, asterisk. This is the cardinal rule. Before you announce to the world that we found ET, you have to be absolutely certain. The protocols demand that the discoverer verify the signal with other observatories, using different equipment to eliminate every other possibility, natural phenomena, a satellite glitch, or even a hoax. No single person makes this call alone. Second, asterisk, asterisk, the announcement, asterisk, asterisk. This is where it gets really interesting. A confirmed detection must be announced in a full and complete open manner to the public, the scientific community, and the Secretary General of the United Nations. No top secret cover-up. The principle is total transparency, ensuring the discovery belongs to all of humanity. But the most critical part of the entire protocol is about what times, not times to do. Third, asterisk, asterisk, do not reply. Asterisk, asterisk. This is the most debated rule in the playbook. The declaration is explicit. No response to a signal or other evidence of extraterrestrial intelligence should be sent until appropriate international consultations have taken place. This means a small group of scientists doesn't get to speak for planet Earth. The decision of whether to reply and what to say is so monumental it must involve a broad international body, likely on the level of the United Nations. The protocols create a global waiting period to give humanity time to think a pause that involves philosophers, artists, politicians, and the public. This ongoing revision is grappling with new challenges, like the rise of private space companies and online misinformation, and it's broadening the scope beyond radio signals to include any technosignature from a laser flash to a megastructure around a star. These protocols are a first line of defense against chaos, but a plan is only as good as its execution. How do you practice for something that's never happened? Section 3. The dress rehearsal. A sign in space. How do you prepare for the single most transformative moment in human history? You run a drill. That's exactly what a global team of scientists and artists did in a groundbreaking project called A Sign in Space. This wasn't a formal NASA mission, but a collaboration involving the SETI Institute and the European Space Agency, ESA, among others. The idea from artist-in-residence Daniela De Paulis was simple. What if we received a real alien message? On May 24, 2023, it happened. The ESA's ExoMars Trace Gas Orbiter, a spacecraft circling Mars, turned its antenna toward Earth and transmitted a coded message. For all intents and purposes, we had received a signal from an extraterrestrial intelligence. The message was crafted in secret. 3 of the world's leading radio observatories detected it, and the raw data was made public. The world was invited to help decode it. What happened next was incredible. A community of over 5,000 citizen scientists gathered on a Discord server, collaborating and sharing code. In just 10 days, this global team successfully extracted the clean-coded message from the raw radio data, a stunning proof of concept for global cooperation. But that was the easy part. The next phase was decoding, which took almost a year. A father and daughter team, John and Sarah, aliases they requested, had the breakthrough. The code, properly arranged, revealed an image. 5 clusters of white dots against a black background. They discovered that the building blocks of the image used the number of pixels corresponding to the atomic numbers of hydrogen, carbon, nitrogen, and oxygen. The message was a depiction of 5 amino acids, the very building blocks of proteins. The A Sign in Space project was revolutionary. It proved that a global public collaboration could successfully detect and decode a complex message, but it also opened up a new set of questions. Even after the message was decoded, its times, meaning times, remains open to interpretation. Is a message about amino acids a simple hello from a fellow carbon-based life form? A recipe? A warning? The project highlighted that decoding a signal is just the first step. The real challenge is interpretation, a process that involves culture, philosophy, and our own biases. Section 4. The game changer. Lasers in the dark. For over a century, we've listened to the cosmos with radio waves. They're reliable, but they have a fundamental limit: bandwidth. Trying to send large amounts of data across space with radio is painfully slow, like streaming a movie on dial-up. If we're going to have a meaningful conversation, we need a serious upgrade. That upgrade is here and is called the laser communication. NASA's Deep Space Optical Communications, DSOC, experiment is a groundbreaking technology demonstration that has shattered our expectations. The DSOC system is a small instrument that hitched a ride on NASA's Psyche spacecraft, which launched in October 2023 on a journey to a metal-rich asteroid. The goal was audacious: prove that lasers could transmit data at broadband speeds across millions of miles of deep space, and it worked better than anyone imagined. Just a month after launch, DSOC achieved first light, establishing a link from nearly 10 million miles away. But that was just the warm-up. On the 11th of December 2023, from a distance of 19 million miles, the team streamed a 15-second ultra-high-definition video of a cat named Taters chasing a laser pointer. Why a cat video? Because what's more representative of the internet and humanity than that? The video was transmitted at the system's maximum bitrate of 267 megabits per second, a speed comparable to home broadband. Throughout its two-year technology demonstration, which concluded in September 2025, DSOC continued to break records. It successfully transmitted data from over 218 million miles away, and in total, the experiment downlinked an incredible 13.6 terabits of data. This isn't just an incremental improvement. It's a leap of at least 10 times the performance of today's best radio systems. As NASA leaders have noted, this technology will transform how we communicate on future interplanetary missions, enabling high-definition video and the vast amounts of science data to be sent from Mars faster than ever before. Now, connect this to the search for ET laser communication would allow another civilization to send us a cosmic Wikipedia rather than a simple hello. And if we were to reply, we could send a vast library of human knowledge. The DSOC project has proven that hardware works, paving the way for lasers to become the new standard for deep space communication and making the galaxy feel just a little bit smaller. Section 5. So, what are we saying now? After all of this, the new protocols, the simulated messages, the laser technology, what is NASA actually communicating to extraterrestrials times right now? Asterisk. The answer is both simple and complicated. The direct answer is NASA is not currently broadcasting any new, deliberate messages to specific star systems like the Arecibo message was. The era of actively shouting into the void is, for the moment, on pause. The focus has shifted from times messaging, times to times listening, times and crucially to times preparation, asterisk. However, the desire to create an updated message is very much alive. A team of scientists, including researchers from NASA's Jet Propulsion Laboratory, has designed a proposed successor to the Arecibo message called the Beacon in the Galaxy, or BITG. This isn't a message that has been sent. It's a blueprint for what we could send. It's a far more advanced, binary-coded message designed for our most powerful radio telescopes. The proposed message is a masterclass in cosmic communication. It starts with prime numbers to flag the signal as artificial. It includes a more precise cosmic address to pinpoint our location, updated diagrams of humans and our DNA, and a clear invitation to reply. The beacon in the galaxy is the letter we've written but haven't yet put in the mailbox. The debate in the scientific community about times, whether times we should send it, is intense. Some, like the late Stephen Hawking, have warned that actively broadcasting our location could be dangerously naive. Others argue that any civilization advanced enough to reach us is likely to be peaceful and that the rewards of contact outweigh the risks. For now, the consensus is to wait, to listen, to prepare. The new protocols are our rulebook. The ASI in Space project was our fire drill. The DSOC laser technology is our new high-speed telephone line. We haven't picked up the phone to make a call just yet. We're just making sure we understand how it works and deciding what we'll say when it finally rings. The Assigning Space project showed that thousands of people working together can solve a cosmic puzzle. What do you think the decoded message of amino acids really means? Is it a simple greeting, a scientific formula, or something else entirely? Let us know your interpretation in the comments below. We stand at a unique moment. For the first time, we're not just hoping for contact, we're actively preparing for it. From the detailed ethical frameworks being debated to the global dress rehearsals decoding simulated messages, we are building the social and technical infrastructure for a post-detection world. The leap from slow radio waves to high-bandwidth laser communications means that any future dialogue could be a rich exchange of knowledge. The question is no longer just, are we alone? But are we ready? And while we haven't sent a new message just yet, We have the stamp, the envelope, and a pretty good idea of what we want to write. Now, all we have to do is listen